To get further information about Kubernetes, please refer to the ECP Kubernetes Guide, Chapter 4, Kubernetes Introduction. Kubernetes is an open-source system for automating the deployment, scaling, and management of containerized applications. Its deployable unit is called pod, and it generally represents one or more containers that should be controlled as a single application. Kubernetes pod is based on a container. In the ECP case, the Docker image is used to execute code in a Docker container. To get further information about Docker images, please refer to the ECP Installation Guide, Chapter 14.2, ECP Docker Images. Docker images for ECP are in the private ENTSO-E Docker repository on Docker Hub, and access can be granted by ENTSO-E on request to the existing Docker Hub account. To get further information about Helm Charts, please refer to the ECP Kubernetes Guide, Chapter 7, Helm Charts. Helm Charts helps to define, install, and upgrade even the most complex Kubernetes applications. Helm is a tool for managing Kubernetes charts, and charts are packages of pre-configured Kubernetes sources. Helm Charts contain several configuration files, such as config map, ingress, service, stateful set, chart, and value YAML files. Each of the configuration file has a different purpose. To get further information about Kubernetes configuration, please refer to the ECP Kubernetes Guide, Chapter 7.3, Configuration. Helm Charts configuration defines parameters of ECP components as well as Kubernetes resources. Configuration parameters are being held in a value file. To simplify the configuration process, values example files are part of the Helm Charts delivery. Values YAML file is a configuration file for the environment. One value file can hold configuration for all ECP components per environment, or each component can be divided into separate values files. The values files contains environment configuration properties together with all available configuration properties for ECP Endpoint. For example, here you can configure resources, liveness and readiness probes, or ingress in case the Kubernetes service needs to be accessible from outside the Kubernetes cluster. Regarding the application configuration, here you can configure any of the supported external databases, netting, and much more. To get further information about deployment, please refer to the ECP Kubernetes Guide, Chapter 8, Deployment to Kubernetes Cluster. Before deployment of the ECP application, the Kubernetes cluster, resources, and others need to be prepared. For more information about prerequisites for Kubernetes, please refer to the ECP Kubernetes Guide, Chapter 5, Prerequisites. Firstly, we need to create a namespace in which the pods will be running. The namespace can be created by the kubectl create namespace command. To be able to pull Docker images, the Kubernetes secret needs to be created. The secret can be created by kubectl create secret command with the following flags. When configuration in values YAML file is prepared, Helm template can be generated in order to check pod configuration with substituted values. Please note that the Helm 3 package manager needs to be installed on the machine where the template is being generated. For template generation, the Helm template command can be used. Fill in the deployment name and chart name and use the F flag to specify the path to the values file. It will be also necessary to specify the namespace using the N flag. Finally, use more than sign to save the result to the file. A generated template can be then deployed to the Kubernetes cluster using the kubectl apply command with the F flag for specification of the template file location and N flag for specification of the namespace. Pod is successfully deployed as a stateful set type. In the case of clean installation, all resources are being created. This can take several minutes until the pod status is running. ECP Endpoint is successfully installed. To get further information about pod management, please refer to the ECP Kubernetes Guide, Chapter 8.4 How to Start or Stop Kubernetes Environment. For pod management, the kubectl console or GUI client such as Lens can be used. To check the status of pod, use the kubectl get pods command with the N flag for the specification or the namespace where the ECP endpoint was installed. As a result, you can see the pod name, number of running pods, status of the pods, number of restarts, and age. To restart the pod, you can scale the stateful set to value 0 using the kubectl scale stateful set command with flag replicas equals 0 and also N flag for specification of the namespace. When the pod is stopped, you can scale the stateful set back to number of replicas 1. Another way to restart the pod is to delete it using the kubectl delete pod command, again with flag N. The pod will be automatically recreated because the stateful set is by default scaled to always run one replica. In case the reconfiguration of the pod is needed, change needs to be done in the values file and a new template needs to be generated and deployed. Use the Helm template command for template generation and the kubectl apply command for deployment. The pod will be automatically restarted. In case you need to get into the pod, the kubectl exec command can be used. To access the ECP Endpoint GUI, you can create a tunnel using kubectl port forward command. The URL will be then available on the localhost address with a specified port. Another possibility is to expose the interface on a public URL using ingress. Please note that in case of ingress, a new DNS record with the pod host name needs to be added to the DNS server or your localhost's file.